Intrinsic semiconductors. In this module, you will learn about intrinsic semiconductors. Semiconductors, as we know, are the materials with conductivities lying between conductors and insulators. Silicon or germanium, most commonly used as semiconductors, occur naturally and are the pure semiconductors. These pure semiconductors are known as intrinsic semiconductors. The atoms of intrinsic semiconductors are closely grouped together in a crystalline pattern called a crystal lattice. Let us consider the crystal lattice of silicon. This is a diamond-like structure. Each atom is surrounded by 4 nearest neighboring atoms. We know that each silicon atom has 4 valence electrons. In its crystalline structure, every silicon atom shares one of its 4 valence electrons with each of its 4 nearest neighboring atoms and also takes share of 1 electron from each of its neighbors. These shared electron pairs form covalent bonds. The figure schematically shows the 2-dimensional representation of a silicon structure at low temperatures. It shows an idealized picture in which all the covalent bonds are intact. As the temperature increases, more thermal energy becomes available to the valence electrons. As a result, some of the electrons may break away from the covalent bonds, thereby becoming free electrons. These free electrons contribute to conduction. Such breaking away of an electron from a covalent bond creates a vacancy in the bond as shown. If the free electron carries charge -q, it leaves a vacancy with an effective charge +q. This vacancy with the effective positive electronic charge is called a hole. An electron from the nearest covalent bond escapes and fills the hole, thereby creating a hole at a new position. The process continues, and this way the hole behaves as an apparent free particle. Thus, in intrinsic semiconductors, there are 2 types of free charge carriers: electrons with a negative charge and holes with a positive charge. The number of free electrons in E is equal to the number of holes in H. The concentration of electrons or holes is also known as intrinsic carrier concentration. When an external electric field is applied to the intrinsic semiconductor, the electrons start moving towards the positive terminal of the battery and the holes start moving in the opposite direction, that is, towards the negative terminal of the battery. The movement of electrons gives rise to an electron current, IE, and the movement of holes gives rise to a hole current, IH. The total current I in the semiconductor is the sum of the electron current, IE, and the hole current, IH. Let us now understand the conductivity of an intrinsic semiconductor at 2 different temperatures with the help of an energy band diagram. This is how the energy band diagram of an intrinsic semiconductor looks like at temperature of 0 Kelvin. All the electrons are in the valence band and the conduction band is empty. An intrinsic semiconductor will behave like an insulator at T equal to 0 Kelvin. The energy band diagram of semiconductors for T greater than 0 Kelvin is as shown in figure B. It is the thermal energy which excites some electrons from the valence band to the conduction band at higher temperatures. These thermally excited electrons at T greater than 0 Kelvin partially occupy the conduction band, leaving equal number of holes in the valence band. The free movement of the electrons in the conduction band contributes to the electrical conductivity of the intrinsic semiconductor, and it starts behaving as a conductor.
Let's recap.
The pure semiconductors, silicon or germanium, are known as intrinsic semiconductors. The atoms of intrinsic semiconductors are closely grouped together in a crystalline pattern called a crystal lattice. In intrinsic semiconductors, there are two types of free charge carriers: electrons with a negative charge and holes, vacancy, with a positive charge. In an intrinsic semiconductor, the concentration of free electrons and holes is equal. Under the action of an external electric field, the total current in the intrinsic semiconductor is the sum of the electron current and the hole current. An intrinsic semiconductor behaves like an insulator at temperature of 0 Kelvin and like a conductor for temperatures greater than 0 Kelvin.